Hi my friends, today we model this part, medium complicated, which has the name ball steam regulator support, and it comes from Timoteo Carrera Soto. This is the assembly and this is our model with all dimensions. This part is taken from Timoteo Carrera Soto drawings, and you can download it by watching the tutorial number 182. This is my drawing, and we start with this revolving object. Dimensions are 105, radius 39, one end is here, 36. This conical volume has dimensions 63 with 43, and let's start. New standard millimeters IPT, new sketch, XY plane. We draw a line starting from the center point with a length of 105. This is an axis, and we create some lines here, up to the right. I keep press the left button. I also keep press the left button. I make coincident this point with this line. I connect the two to have a close contour here. This point is in the center point. Dimensions, this is 39, 11. We draw a small line, a vertical one. You see the two yellow squares. This means that the line is in contact with both lines. Why? Because we applied dimensions in the drawing. This is 63, and this dimension is 43. This is 36, and we have a fully constrained sketch. Finish sketch, revolve, select axis, OK. We continue with these four features. You see them. One is short and the other are to the part. Dimensions are here. You see 18, 75, diameter of 52 at the base. The placement of this face is at 42 from the center point. 15 is this distance. We create a plane based on this, up 42 for a new sketch. A circle of 52, which is construction. Then some lines, as you can see. we place this center aligned with the center point. This dimension is 18, and we apply circular pattern for these 3 lines about this axis, not 6 but 4. I must make this not construction. We'll select each close contour, but I forgot dimension. This is that dimension, 75. This is the fully constrained sketch. Extrude 1, 2, 3, 4, 5. The other direction of 15. I hide this plane, then I create a new sketch starting from this face, but projecting other 2 faces without this. Finish sketch, extrude 1, 2, 3 to the part. Okay. Then we see that there is this feature which has dimensions here 52, 48 and 4. Okay. XY is the sketch. F7. We draw a line starting from this point up to the right, sloped, and we go back to this. It is aligned here. This is an axis. Dimensions 4 millimeters is the thickness. 52, 48. 52 exactly, and 48 is this one. 48. Finish sketch, revolve. Okay. Now we see here that the undimensioned fillets are radius 4. Okay, this means that all around here you see that fillets must be created, but this is not 4 millimeters. We have dimension radius 6. We place that fillets. We select edges of with fillet 4, vertical first, then plus other ones, and that's all, plus this one which is 6. Okay. Now we create this internal void which has dimensions radius 32, radius 8, and the distance of 48. The axis is this one. Good. XY plane, sketch, F7, and we draw an axis 48. It is placed with its center to the center point. This is axis, and we draw some lines and arcs. Start from here, keep press the left button, go up, keep press the left button, go up larger, and we go here and back. You see the 4 tangent constraints. The point is placed also here. These 2 arcs are equal. Radius 32, this one, and radius 8, the other one. Fully constrained sketch, finish sketch, revolve. We have that volume inside, but we cut. Okay. Next is this cut, 44, 52, and the axis is this one. XY plane, sketch, F7, an axis, this axis. We project this and this because we intersect this arc. Then we draw a line up and to this arc. Trim this end here, and let's place dimensions. A point is here. This is 52, not 44, and we place this point on this arc. Yes, coincident point and arc. Then dimension for the point. This is 44. You see, not this, but this is the intersection of the line with the internal cavity. Okay, then I draw an arc from this point to this point. Oh, but I cannot catch it, so that I project this arc. This is construction because I want to draw that arc. These 2 ends and this dimension. A closing line is this one. It is placed under the axis. We have a fully constrained sketch. We have Oh, we don't need this. We don't need this. We need, my friends, these are not important. We need to place an arc outside from this point to this point and to here. Why? Because we cut the volume with all this area. Finish sketch, revolve, cut, OK. You see, this is very good and very nice. Now we have to create this face in order to place there some other features. The position of this plane is 91 minus 16 measured from this line. Let's do this. Plane from this face down at you see the sign, yes, minus 91 plus 16. See, this is the plane. I want to make it larger. Auto resize. Now we see what happens. This is the plane for a split. This is the tool, and we select up or down. Down is the direction of the cut. Yes? Okay. The plane is no more necessary. Good. Now we place that features. You see this contour. Dimensions are 16, this 16 from 91, but the other dimensions are here, 56 and 35. Okay, we have everything here. Let's do this. XY plane, sketch, F7. We project this face and we draw lines. This is the axis. This will be the axis. Horizontal, down, right, and close. As I said, this is the axis. I place it coincident with the center point. I place this line, not that line, this line aligned, this line aligned with this. Then I project this line to make collinear these two. Dimensions are this one, which is 35, and the other one 56. 56. This distance is 16. Okay, finish sketch, revolve, select profile, this and this. We didn't make this construction line, and now we have problems. We add volume here. Okay, Now if you take a look here, there is a radius of 6. We apply fillet of 6 here. Okay. We have to create other cuts, but we start with this metric 22 with a pitch of 1.5. You see, here is a dimension which is not clear for us today. This is Whitworth thread, I suppose. But what is its 21? 21 inches? I don't know. I place here metric 22 with a fine pitch, which is 1.5. So I place this firstly as a hole with the thread, this face and this center. The definition is isometric profile, 22, pitch 1.5, and the hole goes to this face. Full depth is the thread. Okay. Okay. Good. We continue with dimensions 34, 21, 4 millimeters here, like this one, 4 millimeter again, and 24. Let's place these lines which compose a sketch. I draw a vertical line between this center and this center. This is the axis. Then I draw a line here, another one here, another one goes anywhere here. Then another contour is a rectangle with dimensions tab 4 millimeters, and this is diameter of 24. Here we have dimensions. This is 21. This is 34, and this is 4 millimeters. Fully constrained sketch, finish sketch, revolve. One is this, other is this. This. Select axis. This is the axis. Cut. OK. Now I see that here is something unexpected. Why? Because this revolve was not well placed up. Let's see where is the sketch. This is the sketch. Double click, F7, and we don't align this with this line, but with this point. I delete this line and I draw another one between these two lines, and I take care to project to place at this end this line, you see, then trim here. Now this contour will be not outside this conical face. Finish sketch, it disappeared. Now we create these 4 holes. Dimensions are here. 4 holes of diameter 8 placed on the circle diameter of 64. The depth is 34, and I see that it goes outside. Timoteo doesn't observe this, but I respect dimensions here. Good. Let's see how to continue. 34 measured from here. We select this face, or better this face, for a line, only one line. This is half of 34, half of 64. 64 divided by 2. 64 divided by 2. Then we place here a hole, not threaded, on a distance, placed in this point, diameter of 8, depth of 34. Okay. Then we apply this hole around the vertical axis. Circular pattern of the last feature about this axis, not 6 but 4 instances. Okay, now we know that this is not well placed. Let me create another hole from the drawing. This one, diameter of 16, to this internal hole, or through all. Hole, position face, position center, through all, diameter of 16. Okay. Now I select this plane XY to create a new sketch. F7. We see that this hole is not through. This is that small mistake. No problem with this. To create the full hole, I apply another one over this one. Hole, select positions, this face, this center, diameter of 8, and distance is to this plane. Yes, here. Okay. Other holes are this 4 and this one. Let's see what are the dimensions. You see here this hole which has no dimension up. Let me place it. This is 8. The diameter is 6. The depth is 6. And flat end. We create a sketch here. XY plane, F7. I project this line. I draw a rectangle. This rectangle. This is the axis, not construction, but axis. Diameter of 6. 6. Distance of 8. 8. And the depth of 6. Fully constrained. Revolve with cut, and you see the result. Then we apply circular pattern for the last feature about the vertical axis, 4 instead of 6. Okay. Dimensions for the last hole are here. Diameter of 6, 35 from the left, and a chamfer 2 millimeters. I use this plane, F7. I draw a circle with diameter of 6, placed on the same horizontal with the center point at a distance of 35. Finish sketch, extrude with cut the other direction, cut through. Okay, chamfer of 2. 2 is by default. Okay, now I made a sketch here only to see inside. I delete this sketch. Good. Also good. And now let's see what is the volume. Properties, physical, update, copy, close, drawing, double click, paste. Oh, there is a small difference here, so that we keep the last value because this is what we did here. The part is made of steel cast. The color, general color, is red. We select some faces for machining. That is one. I keep press the shift button to select all of them. And the aspect is still polished. We apply view with shaded and we compare the two. You see? No differences. Okay, that's all for today. Thanks for watching. Bye bye.